Thank you. Good afternoon. So in the morning session, we are talking about the soil. What is the soil and what are the index properties? And based on the index properties, how to classify the soils. So we have learned about that. So now we'll talk about the engineering properties of the soils, which are based upon the index properties. So we are talking what are the engineering properties and so on. In the morning, we have already learned that what is index properties. These are the properties. So now these are the strength properties. Compaction. Compaction is you are increasing the density of the soil by increasing permeability. The permeability is the property of water is passing through the soil. Compressibility. Compressibility is the property when you apply the load. Whatever the soil is in, compresses. Shear strength, the base of the soil, shear strength. So now soil compaction. What is soil compaction? Anybody? What is the process of compaction? Anybody guess?
The rights from the soil. Moving the rights from the soil.
Manually, what is the any practical use or you are all working? Yeah, because you are what you are doing, the compaction process, you are using the rollers. Yeah. So in that way, you are increasing the density. Increasing the density, reducing the gravity, increasing shear strength. So now what is the process? So this is the picture. On the left side, you see there is a normal soil is there, and the soil has the you can say particles on the wires. When you apply the volume, you have decreased the volume, mass is the same. So that way we are increasing the density. So this process is called as the compaction. This is the most important process in case of the other environment or any other device. Because whatever the material, whatever the structure, your embankment you want to construct with the soil, this is the process you have to follow. So in case of the soils, so we will discuss how to what are the densities, how to achieve that. So in case of the soil compaction, there are the two terms. One is the maximum dry density, other is the optimum osmosis. What is the maximum dry density? Because when you want to construct an environment design, I think everybody is aware about that. So what is the maximum dry density?
The density dependent.
Yeah. Right? Anyone? The maximum dry density is the density that can be achieved in a particular soil under a particular it's a particular soil. So this is called as the maximum dry density. And what is the optimal moisture content? This is the moisture content on which you can achieve that density. So this is called as the optimal moisture content. So how you determine these OMC and MDD in the laboratory? This is the field compaction. Okay. So here you can see a roller is there. Okay. This is called the sheet foot roller. Depending upon your soil, you decide which kind of the roller you use. What is your you can say positive soil? If that means what kind of the roller is you use? Sheet foot roller. So if it is a possible as well, like say for example, what kind of the roller? Vibrating roller. Good. So this is the vibratory roller. So basically, to determine the MDD and OMC, we do the two types of compaction. One is the standard Proctor compaction test, other is the modified Proctor compaction test. So first we talk about what is the standard Proctor test. So these are the machines which are used for the combustion process. One is the hand compactor, other is the machine compactor. In case of the hand compactor, primarily on the left side you can see the pointer, pointer, pointer. On the left side you can see there is a hand compactor. Like this you can say the regular release. But on the right side you can see there is an automatic compactor. Here all the you can say here all the compacting compactor is inside of the compacting machine. The thing is that you have to put the soil in the mold. At the top there is a counter is there. On every 25 load it is stopped itself. So how to do the compaction process? Now again, depending upon the material size, whatever the particle size, so we take the compaction mode. Here are the two kinds of modes are there. One is the one. If the particle size is less than 90 millimeter, then we take 100 mm diameter. And the volume of this mode is 1000 cc. For this mode, in case of the standard Proctor, the mode is filled in 3 layers, and each layer is compacted by a rag of 0.6 kg, which falls from a height of 31 centimeters. But if so these are the general dimension of the modes. But when the material size is more than 19 mm, then we use 150 mm mode. The volume of the mode is 2250. Here we use the same kind of the rag of 2.6 kg, which falls from a height of 31 centimeters, but the number of the flow is different. Here, depending upon the volume of the mode, every layer is equal to 55 pounds. So this is the standard Proctor test. This is again as second one is the modified Proctor test or the heavy movement test. In case of the heavy compression, depends on the same again, depending on the particle size. The particle size is less than 90. It is the same 100 mm will be used, but here instead of 2.6 kg, we are using 4.89 kg. When it falls from height of 45 centimeters, the mode is filled in 5 layers. Instead of 2 layers, it is 5 layers. That is the difference. Again, the particle size is more than 19. We have to use 150 mm mode. And here again 4.89 kg weight diameter. And it will fill again 5 layers, but every layer will complete 5 rows. So, which can you tell me if we are supplying some energy? So, if we talk about the ratio, how much is the energy we are supplying? Based on the light consumption, we are supplying the energy 595 kg joule per cubic meter. But in case of the modified Proctor test, we are supplying the energy 2674 kg per cubic meter. 4.5 times of the standard Proctor test. So now we are working the field. Okay, want to concentrate on that. Which one you will choose? Now the question arises here. We have two methods of this field. One is the standard Proctor, other is the modified. And you have been asked, okay, take the YMC. YMC you can give by the standard Proctor, right, and modified Proctor. So which method you will use? For my first one. Very good. It will again depend on the height. More the height, more the specificity. So normally, if you calculate up to 30 meters, we go for the standard Proctor test. But if the height of the diamond is more than 30 meters, then we will go by the modified Proctor test. Okay. So what is the process in it? First of all, you take the sample, air dry it, don't go and air dry it. Okay? Air dry it. 30 meters side is the height. If you calculate the pressure is just calculate the pressure. What are the pressure is coming on the water? Okay. According to that, and if you do the slope space analysis, so normally for up to 30 meters, general property is good. But if the height is more than 30 meters, then height is benefit. Second is what is the process? How we do it? Yeah, this is your mold. We want you to take the sample and air dry it completely 4 to 5 days and take the 4 to 5 days. Depending upon the acid, 90 ml samples and some water. Now the question is how much water should we have? Then you will get what the unshaped ones. The thing is that if you are using non-toxic soil or the anti-soil, there also should be around 8 to 10 or 12 generally. But in case of the toxic soil, buoyancy will vary 50% to 30%. So first of all, this is what kind of soil it is. Depending upon that soil, we add some water. Suppose we are talking about the toxic soil, so we will start around 8%. Okay? At 8% moisture content, mix it thoroughly and keep it for some time. Why you keep it for some time? In the morning I told you, and you determine the other limit for the toxic soil. You have to keep it for some time so that your soil can absorb the moisture properly. Keep it for some time, and after that, we fill the mold up to 1/3 height, and whatever the method, modify the method, yeah, standard doctor, either 25 rows, yeah, the first layer, after that, fill the second layer, and third layer, each layer will be 25 rows. When you fill it completely, take out the collar, take out the base plate, and make a both end flares and weigh it. Determine the motion method. After that, what you do? Add some increment of the water. Increment means suppose you have taken 3 kg, take 3%, 2%, and again mix it thoroughly, they do the same process. Determine the motion content. In that way, you carry on until unless. Initially, what you find the weight of the well as you bring the water, the weight of the mold is increasing. But after a certain time, the weight of the mold starts decreasing. Stop that pressure. So what is the function? Why am the water in the soil? The morning you are asking something. Yeah. Why am I adding the water in the soil? Initially, it start increasing. And after a certain time, no word. Can I go to the right? Why I need water? Basically, when you talk about the soil particles, they have a different kind of thing. So they have interparticle frictions and interparticle locking. Okay, when you add the water, they reduce the friction force on the. So when you apply the mechanical energy, what they do? They slip to the new positions. Okay, in that way, the water is reduced. When you go on adding the water, so it will saturate the pores. A limit will come when all the pores are filled. If you add some more water, the volume of the pores start decreasing. At that time, weight of the body start decreasing. So that is the limit. So this is the thing. This is the you can say data of the one test. Here you can see. Initially, the weight of the mold is increasing 3768, 3924, 4045, 402, 88, 402. It is starting to then stop the test. Now, this is the you can say wet weight of the soil, and this is the you can say wet density 1.759, This is the moisture content we have decided for cycle. And depending upon that, then you can see. Okay, here you can see that there is a minimum weight is here, but when I determine find the maximum drag density, my density is coming here 1.80. Okay, so because in case of the compactor, we don't know when we achieve the maximum drag density, so we continue to go on until unless the weight of the board start increasing. So after that, you plot a curve between the motion content and the drag density, and this curve is look like this one. This is called as the maximum drag density curve. So this is your maximum drag density 12.650 maximum density, and the motion content corresponding to this density is called as the OMC. So this is the curve. This is very important for you. For the embankment, this has been done, and you are asked to achieve the same condition. For that, you take this and you fix the water in the soil and fall it in the field, and you decide how many passes are required to achieve that density. So this is again first curve is the standard Fokker curve. This one is the standard Fokker curve. But if you do the heavy compaction, what will you do? The density is increasing, but the moisture content decreases. Okay, so it means more energy you are supplying to the soil. It increases the density, but again decreases the moisture content. Its volume is decreased. So this is the saturation line, 100% saturation line. Actually, when we talk about the you can say compaction, the soil is around 78 to 80% saturated. So normally in the field, you are asked कि भाई आपको जो कंबेक्शन करना है वो 98% डेंसिटी से because in the field we cannot receive because laboratory में we do the test in the control field. At the site it is not possible. So normally what is the S code after the compaction after the body layers the density should be 98%. But technically it should not be less than 95%. Because more less than density has the word rotation and the so here there are the two motion containers there. This is my MC line. One on the left side and the other on the right side. Left side is called as the drive of the optimal and the right side is called as the weight of the optimal. Now there are two motion containers. One is here and other is here. So now the point arises, which motion container I should take that.
That's what condition.
What condition?
मैं ट्राई नहीं
पॉसी नॉन पॉसी कोई चीज अलग हो गया पॉसी में जब आप मिला रहे हैं तो उसका तो डेंसिटी मतलब उसका मोशन ज्यादा होता है और नॉन पॉसी सॉइल में जैसे के सैंड का एमसी कम that is different here you have got the two density two motion content for the same density. So these are the you can say peculiar behavior of the soil. So depending upon that, we talk about the drive of the optimum and the weight of the optimum. So there is a big difference in the soil structure. On the dry side, soil structure is populated, and on the dispersed side, wet side is dispersed structure. Populated means the soil particles are you can say sometimes they are not joined by n. Okay, like this one particle is here, other particle is like this one. Okay. So they have the big weight. But in case of the dispersed issue, they are the parallel. Let's see, like this one. So these are the dispersed section. In dry side, it has more shield strength. The wet side, it has the less shield strength. Dry side, high probability, more swelling, brittle failure. On the wet side of low probability, less swelling, ductile failure. Okay. So these are the difference. So when we talk about the environment, like we can say water reading structure, so there the two phases are there. One on the reservoir side, upstream side, other on the downstream side, which is well. So depending upon the phase we use, when we are using for on the upstream side, we go for the dry audio. When we are going on the downstream side, we are the one thing we have low probability, it should be ductile. Okay. Then we go for the wet upgrade. Did you clear everything else? Okay. Next thing on the permeability. So what is the permeability? The permeability is the characteristic of the soil by virtue of the water flows through the voids of the soil. Any material which have a continuous force is called as permeability material. Because if the pores are not interconnected, water will not. Soil is a porous material. We talk about that. So why we determine the permeability? It's because most of the sector has an environment we have the water retention. So permeability is very important. The main function of that one to stop the water to go through it. The main function is the function of the permeability. First thing is that depending on the permeability of the structure environment, you will determine how much seepage is. And if you talk about the foundation, so you also determine the permeability of the foundation. How much seepage will take place through the foundation. Second is when the water passes through the foundation, we will apply some certain pressure on the foundation. So by knowing the permeability, you can determine how much pressure will come on the foundation. Third is the uh, settlement of the bodies. How much is your dance near the foundation will settle after? Because you are using a soil at OMC, it contains some water. Okay. So after that it will settle. The settlement will, the rate of the settlement will depend upon how easily water will come out. If your soil is highly permeable, the water will come, the settlement will take within months. But if you are using permeability soil which have a low permeability, okay, then it will take years to settle. So that is also important. How is it to determine the yield of the well? It is very common in every village and every city. You make the well which is Nagapalika wells, okay? They drain the well. How much water you will get from them? That also depends upon the permeability of that strata. So permeability of the soil is what is shape and size, void ratio, properties of the permeate, the saturation of the soils. I am saying that it will depend upon the saturation of the soils.
Dry soil or wet soil options. Dry soil, non-permeable soil.
Anybody know? Will in fact make my statement is correct. The saturation of the soil factor in the soil. Yeah. If you talk about the soil everything is this one. Soil has soil particles, water, and rain. So very near like this. Near like this in pores. In pores, there is water and there is air. Here, okay. So what will happen when the water will flow? It is fully saturated. Then water will flow easily. Okay? But when some air is there, point is that it contributes the, you can say, flow channel. And it creates obstruction in the flow of the water. So if it is the fully saturated soil, the permeability will be high. If it partially saturated, permeability will be low. So depending upon the particle size, again, from the morning, we are again coming on the particle size, particle size. Depending upon the particle size, the permeability will vary like this. If you talk about the clay permeability has 10 to the power minus 6 centimeter per second. Less than. If you talk about the 6, the permeability will vary 10 to the minus 4 to minus 6. Okay. Okay, this is whole sand permeability. And if you talk about the sand, permeability will vary until the -4 to 1. Depending upon if it's fine sand, medium sand, clean sand. And if you talk about the gravel, the permeability of the gravel is always more than 1. So these are the general idea if there are this kind of soil, okay, permeability doesn't exist. Now the question is how to determine the permeability. So there are the two methods to determine the permeability of the soil in the laboratory. First is the constant head method and second is the falling head method. Okay.
तो ये ग्रेवल होते हैं और एक क्ले होती है वर्ड रेशो किसका ज्यादा होता है इसका ऐसा क्ले का ज्यादा होता है तो फिर उसमें क्ले की परमानेंट कम होती है ना
क्ले के पोर्स बहुत फाइन होते हैं देखो बहुत फाइन होते हैं अगर मैं इफ यू टॉक अबाउट द मोरल स्ट्रक्चर ना तो उसमें प्रोबेबिलिटीज के अंदर उसका वॉल्यूम जो है वर्ड्स का जो वॉल्यूम होगा वो क्ले का ज्यादा आ रहा होगा ठीक है लेकिन उसके जो पार्टिकल साइज नंबर ऑफ पार्टिकल की साइज देखें ना लेकिन वर्ड रेशो बहुत कम होगा ठीक है तो इन केस ऑफ ग्रेवल की आप जब बात करोगे तो वर्ड रेशो उसका ज्यादा रहेगा मतलब उसका जो कोर्स की साइज की हम बात करते हैं तो किस में ज्यादा होगा ग्रेवल में ज्यादा होगा या क्ले में ज्यादा होगा वो ग्रेवल में ज्यादा होगा तो जिसके कोर्स बड़े हैं उसको मिट्टी किसकी ज्यादा होगी जिसकी कम होगी या जिसकी ज्यादा होगी ज्यादा वाली
रेशियो लिखा था सर आपने
कहाँ पे
पीछे स्लाइड में
रेशो नहीं है वर्ड रेशो इसका नाम वर्ड रेशो कहते हैं इसको वर्ड रेशो क्या होता है बेसिकली वर्ड रेशो होता है वॉल्यूम ऑफ द वर्ड्स वॉल्यूम ऑफ द सॉइल मास ठीक है so constant head method or falling head method where we use the term constant method falling head method
उस ग्रेड में फोर्थ ग्रेड सॉइल में कांस्टेंट और फाइन ग्रेड सॉइल में
falling that's good why
तो फोर्स उसमें कम होता है ना फाइन ग्रेड में कांस्टेंट हेड पे जो सीपे जो है उसका वॉल्यूम बहुत कम टाइम और फॉलिंग हेड में थोड़ा सा प्रेशर ज्यादा होने की वजह सफिशिएंट अमाउंट में सीपे हो जाता है वाटर कितना ज्यादा टाइम लेगा ऐसा उसमें कोर्स में कांस्टेंट एंड वाटर सो पार्टिकल से टाइम फ्लो करते हैं
पॉइंट इज दैट अभी मैंने इससे पहले जो मैंने टॉकिंग अबाउट प्रोबेबिलिटी जब हम पहले फाइन ग्रेड सॉइल तो प्रोबेबिलिटी इज वेरी okay but if you talk about the time okay even for the collection of the small time you require quite long time could be months okay but in case of the post grade soil the probability is very high in a very short span of time within 1 and 2 hours you can collect a sufficient amount of the water so that is the main difference okay. So in case of the constant head method we use for the sandy and sedentary soils, okay, when the probability is high. And falling head method we are used for the clay soil when the probability is low. So this is the you can say apparatus we use for the falling head method. In the falling head method, but we use this is the probability mode and it has the same dimension as the compaction mode. Only thing is that here we have provided some you can say water is supplied through this bottom pipe and it will come out from the top. And these are the you can say stand is there. Here you can see there is the water column is there. Glass water column is there. Water is filled and the level of the water is measured by this scale. The scale is attached here. So what we do? You take the mold and you compact it with the permeability mold. After the compaction, you attach this water column with the help of flexible pipe to this mold and fill the glass cylinder with water and take down the note down the initial water level. After that, you measure the water level at different time and you find out that it is falling at a constant rate at a time and the water is coming out from the top of this one so no soil specimen is saturated. After that, you collect the certain. After that, you note down how much water is falling in a different time intervals. So this is the things. You have taken the first reading, and after suppose time will be 2 hours, 3 hours, 4 hours, depending upon the size. Because if you have the clay, then it may take 24 hours. You are taking the ring after 24 hours. But if it is a facility, so you may have taken the ring after 4 hours, it takes 3 hours. So depending upon that, to determine that, okay, this is my water level, it is falling in 3 hours, 1 hour up to that height, and you determine the coefficient of the probability. By this method, this is the H1 initial height, H2 is the final height, and the T1 and T2 is initial and final height. A is the area of the standpipe with glass cylinder. L is the length, and the yeah. This is given probability in centimeter percent. Other is the constant head method. So this is the constant head. This is for the sandy soil. Here, same thing is here. Sample is packed like here, but here there is an overhead tank is there, and the water is continuously flowing in this tank. So we maintain the water level constant. So in any time interval, suppose 1 hour every hour, we collect the water. Whatever the water is coming through the specimen, we collect the water. Suppose in time 1 hour, 2 hours, we have collected the 1 liter, 2 liter. We determine what is the discharge rate. And depending on the discharge rate, we determine the probability of the soils. So this is the formula. 2 is the total discharge. Time period is the samples. So anything about the probability? Now the consolidation. What is the consolidation?
Removal of water from soil. Removal of water from soil.
Good.
So it's a long-term process that in which voids of air extracted out along with water. The compaction is short-term process. This is a long-term process में अगर load लगाते हैं कुछ ले सकते हैं.
This is one of the characteristics of the consolidation. So have you seen the sponge? Okay, suppose sponge is filled with the water and you compress it. What will happen? The water will come out here. The same thing is happening in the soil. When the soil is subjected to the compressive load, when it is saturated, so what will happen? The water will come out from the soil. And the soil will compress or settle. Now the rate of the settlement will depend again on permeability. If the permeability is low, then the water will come out very slowly and it may take long time. But in case of the sandy soil, you apply the load, it will compress instantly. Okay? So in case of the clay soil, when the permeability is very low, it may take 100 years, 50 years like that. But in case of the sandy soil, it may settle within few hours. So consolidation is the process in which under the compressive load, the water from the voids of the soils comes out and the soil settles. So this process is called as consolidation. Why we are talking about that? Because when we are constructing the embankment, we are using the soil at OMC. At OMC, soil is around 80% saturated. Okay. And if it is in your water retaining structure, over a period of time, it will soak the water from the reservoir and it will be saturated. But since it is because there is structure is there and the stresses are coming on it, that is the compressive load, it will start settle. So that time by consolidation test we determine how much time it will take for the settlement and how much settlement will occur. Because how much settlement will occur is very important. Suppose you have constructed your embankment, you need some freeboard, 1 meter, 2 meter like that, depending upon your structure. So you have to take into account the proper how much settlement it will take. Otherwise, what will happen? Suppose it is settling more than freeboard, then what will happen? The water will overtop it, and your structure is going to be washed out. So this consolidation process will determine how much settlement will take place. So this is three-phase system. Now this is the thing, how the consolidation takes place. Let me. So this is your basically the soil. It contains soil particles when it's fully saturated, and it contains the water. You apply the compressive load over it. So what will happen? The water is there. So all the load is taken by the soil particles and the water. Due to the can say water pressure, excess pore pressure will develop in the water and will start come out. Okay, so the volume is decreasing and the soil particles are coming to closer. This is the settlement of it in case of the consolidation. Here we can explain it with the help of the springs also. The same thing is there. The cylinder is here and it is fit in the water and at the top it is attached with the piston and the bottom of the cylinder and if you apply the load over it, so there is a pipe is there, the water will come out. What will happen when you apply the load at here? After certain time, it will come in equilibrium position. Okay, whatever the due to the string stiffness equal to the applied load, and the water, whatever the excess water is there, that will come out. But if you further increase the load, it will again come down. Water more pressure will develop, and the water will come out. Again, it will reach a new equilibrium position. So in that way, consolidation take place. So how we determine the laboratory? So there are the three types of consolidation. One is the initial consolidation, second is the primary, third is the secondary consolidation. So what is the initial consolidation?
So immediately with that.
Immediately with that, right? Okay.
So primary the water and secondary is a plastic readjustment of soil particles.
So because what happens in when you apply the compressive load of the soil, there is some let's say you cannot saturate in any soil 100%. In laboratory also you can achieve up to 98%, but achieving 100% will take a lot of times. Okay. So when the compressive load comes over it, whatever the air is that will come from the air and there will be instant settlement. So that is called the initial consolidation. Secondary is the primary consolidation. Basically it is important. When the initial after the initial consolidation, the water will start come out from the soil and the settlement take place. The time of the settlement will again depend upon the permeability of the soil and the final position is there when there is no further settlement. It is called as the permeability. It is a very slow process. Next is the secondary settlement. What is the secondary settlement?
It is the structural change of the soil. Particle adjustment.
Basically होता क्या है? Once primary consolidation is complete, even after that, there is some settlement like peak. Have you heard peak? Under the same load, with a over period of time, there is settlement. Same thing happening in the soil sample. Okay. Because the point is that when we talk about the soil, we see the soil particle interconnected. No. Because between the soil particles, there is a we can say liquid is there, quite viscous liquid is there. Okay. Due to the load, that some water from the viscous will come out and they have come closer. So in that way, secondary consolidation takes. So these are the parameters which we determine from the help of the consolidation. First is the consolidation coefficient of the compressibility, coefficient of the volume change, compression index, coefficient of the consolidation. So coefficient of the compressibility means how much word ratio will change if you apply the pressure. Coefficient of the volume change means how much volume is going to be changed due to the consolidation. Compression index, it gives the two curves in case of the consolidation. One is the compression curve when you apply it, and when you release the load, it will swell. Okay. So this gives the compression index. Last one that is not visible, I think here, coefficient of the consolidation. This is the most important. It will tell you how much time it requires for a soil to settle completely. The most important is coefficient of consolidation. We are interested for that. And the volume coefficient of the volume change. How much volume is going to change? It will give how much your structure is going to settle. So this is the picture. In the morning I shown you. So this is a big mistake. I think in 1400 it was built. And at that time, people don't have the idea about the consolidation. Same thing has happened because it is built on a highly compressive forest. So after some time, it did start settlement, and now it has been reached around 5 meters. We talk about that. So once the construction is over, so these are the parameters we should exactly know before starting our project, our embankment, how much is going to happen. So these are the machines which are used to determine the consolidation. This is a fully automatic consolidation apparatus. So in this fully automatic, this is our consolidation set where we keep the sample, and here we apply the load, and both load versus deflection both are measured automatically, and this is a computer here and which calculates automatically how much all the consolidation parameters like temperature index, it calculates automatically. These are the manual. Most of the laboratory you will see like this one as well. So here we measure the deflection with the help of the dial gauge. The load is applied on this here. So we take the continuous reading for the 24 hours because for each load you have to measure the load deflection of the sample for 24 hours. So this is time consuming test. It takes maximum time. If you want to complete a consolidation test, it may take around 15 to 20 days. Depending upon the swelling, if you want to know the nature of the swelling also, because once you are loading, again, if you want to know the swelling characteristics, then you will again start its unloading it the same way. The same time you want for the swelling characteristics. So how you perform the test? Yeah, this is the picture. So basically, for this test, there is a consolidation machine. We have already seen that this is the consolidation cell. So here you can see it here. There is a consolidation ring is there. This is the ring which has the diameter 20, 60 mm and height is 20 mm. So we take the sample that pass through the 22 mm, and at the OMC, if we have determined the OMC, it means the water is flowing to OMC and pack it here at the MDD. After that, we keep the specimen in the ring in the cell. At the top and the bottom of the ring, we keep the two filters now. Because when the soil is compressed, the water will come out through the filter, and it is not directly in contact of the water. So this is a typical picture. This is the typical picture. This is not working. This is your soil specimen. This is the top filter. This is your bottom filter. Okay. This is the top here. From here you apply the compression load. So when you compress this soil, the water will come out and it is come out to the cell. Yeah, either there is some arrangement there, you can water will come out from here. So what you will do? You pack the sample. First of all, fill the soil with the water and let it saturate. So how will you know? To determine the saturation, there is a dial gauge which is there on the top of the load, from which you measure the constant continuously. What is the reading of the dial gauge? Initially, the reading will increase. Yeah, the dial gauge is there. So initially, when it's swelling, the reading will increase. When it becomes constant, you apply the first load. If you want to determine the swelling pressure, then apply the load of 0.05. Otherwise, goes in 0.25 kg percentage star load. And after you can say put the load, take the dial gauge reading continuously at 0.25, 1 minute, 4, 6.25, 9, up to 2 hours, take like this one. After 2 hours, take every 1 hour. And take the reading for the 24 hours. Once you have taken the reading for the 20 hours, apply the second load, and again measure the reading. Now, depending upon what pressure you want to test it will again come from your height of the embankment. So, what pressure will come? Normally, we test up to 30 meters. it is up to 8 kg pressure equivalent, but if height is more than 30 meter, then you will have to test a passive pressure of 16 kg per centimeter square. So this is the pack sample. You can see it here. In case of the foundation, we get the undisturbed sample. We are talking in the morning about the undisturbed sample. Because in the foundation we take the undisturbed sample, in that way we determine how much the settlement of the foundation will take. So here we take the, you can say, chunk sample. There are some block is there, and we insert the ring inside this soil chunk like this. And we prepare the sample. So now we have the damage reading for each load, and you have the time and what is different time. So you plot a curve between the time and the deflection of the curve. Time is taken on the sunny log graph because you have to plot the 24 hours right from the let's say 1 minute to 24 hours. That's why we have taken the log scale on the x-axis, and the deflection of the curve is taken on the y-axis. So this curve is called the consolidation curve, and for every load you have to plot for this 0.25, 0.5, whatever the load you applied. For every load you have to plot this curve. From this curve you determine what is the time for the 50% consolidation. This is the E log P curve. When you apply the load, how the void rush is changing. Pressure is, this is the pressure is here, void rush is there. You know, this is a 0.25 load. You have applied this one, void rush is decreasing. Again applied load, void rush is here, again applied the load. Okay. So this sample was tested up to 8 kg per centimeter square. After that, we want to know the swelling characteristic. Remove the 4 kg load, it will start swelling like this one. So the slope of this curve will give the compression index, and the slope of this curve will give the swelling index. The state portion, this one, not that one. The state portion will give the compression index and the swelling index. So important is the coefficient of the consolidation, which will give us how much time it takes a soil for the complete consolidation process. So to determine the consolidation coefficient of the consolidation, there are two methods. One is the Taylor method or the square root of the time method. In that case, CV बराबर होते हैं TV 90 D square by T 90. What is T 90? It is the time factor for the 90% consolidation. It is 0.848. D is the average drainage path, and T 90 is the time for the 90% consolidation. We will check it. D is the average. Here in the picture we have seen that we have put the filter on the top and the bottom of the specimen. So and the specimen size was 20 units. So what is the length of the drainage path? 10 mm. 10 mm. Good. Okay. And in case we allow for the single side drainage, 120. 20. Good. So in case of the time consolidation method, what we do? We plot a curve between the square root of the time and the deflection of the specimen. So this is my curve, and this is the square root of the time. Now we extend the initial state portion. After that, we draw a line which has the ordinate 1.15 line of this line. Here this line cut this curve. That will give us T90. Got my point? Now you know the T90. By using that formula, you can calculate the coefficient of the consolidation. Second है logarithm of time fitting method or the Cassay Grande method. In this case, we determine the T50. T50 means how much time will take for the 50% consolidation. Earlier in the case of the pillar, how much time it will take for the 90% consolidation. So to determine the T50, we plot a curve, but here time is taken on the log scale and the dial gauge reading on the normal scale. From this curve, this is the Middle portion will be the state portion. You extend this state portion, and then the last curve portion, draw a tangent from here. Where they cut? That will give a 100% consolidation time. So second thing is what is the 0%? So for the 0%, we have taken the reading 0.25 minutes and 1 minute. We draw a line, horizontal line. So this is the difference. This is 0.25, this is 1. We take the point, same again, and we draw the line. This will give you the R0. Now you know the R0, you know the R100. If you take the half of that, will give us the 50% consolidation. And where this curve, it will give us the T50. This is our T50. Once you know the T50, you can determine the coefficient of consolidation. So this is the table. Here, this is the diffraction of the samples. Value rings are there. Okay, this is the pressure. And on based upon that, we have calculated how the void ratio is changing, how much the existence are coming, and we have calculated. This is the type. We have calculated the T50 from the graph. These are the value of the T50. From here, we have calculated the value of the CV. So these are the value of CV. From here, you can see we have calculated the value of the MV, coefficient of the volume change. It is a quite complex test. And it requires some mechanical practice. Anything about the consolidation want to discuss?
Sir, in case of consideration, some may say that's right. CC equal to liquid limit minus K.
Yes, those are the empirical formulas. Basically, you know that soil has different properties, but somehow, as I told you, to complete the consolidation, it takes a lot of time. Okay, so somehow if you know the basic properties and S properties, from that you can guess some it. If this is my, you can say CC value, other things. But to know the exact value, you have to analyze. Those are empirical values. And those values are in the site specific also. Because might be the who has given this value, who is a foreign researcher, their soil may be different from our soil. If he is saying the CC equal to 0.09 and WL minus 10, so here might be we can say WL minus 3, depending on the soil. The nature of the soil depends on, let's say, region to region. In India also, if you talk about the northern region and southern region, there is a quite difference in region. In south you find most of the, you can say, clay soil is there. But in the northern side, normally alluvial soil you will find there. So that depends on that.
So what is
Well, we should not steadily apply whatever the empirical condition is.
so in primary investigation, can I use this formula in case of suppose the article pregnant, in case some parental is required by the some purposes, so then in that case
only for the some empirical studies कि how much the settlement will take for that one. But for the exact to determine the exact settlement, you need the actual parameters.
So one thing is another testing is given for. So someone is the manual procedure, another is the automatic procedure. So the automatic is the timing is same or different?
So there is some differences here because you know what exactly in case of the manual procedures, what we do, we take the continuous like up to 24 hours. We don't know suppose in office hour how much your office hour you are working 8 to 10 hours. But test me continuous for the 24 hours. It might be after 15 hours. Okay, your settlement is become constant. But you are coming in the morning. So we change the load in the morning. But in case this case automatic update test, it will it will find out okay my let's say the settlement has become constant. It will change to the next load. So in that way you can save some time.
So what is over consolidation? Over consolidation.
Over consolidation. Something from the test. what you find in the past, it might be some heavy vehicle, some heavy load, whatever you load you are applying for the consolidation, it has been experienced some higher load before that time. So once it is compressed, because it is not elastic material, okay, it will swell it, but it will not behave like a normal soil. Okay, so what will happen? It will give you the essential consolidation property. It will not give you the proper consolidation. It will affect your consolidation, option consolidation, total settlement. So this is called as the over consolidated soil. Now the question arises: how you find out the over consolidated soils? So the means to determine the over consolidated soil, the OCR should be less than 1.
Over consolidated
Greater than 1. Sorry, greater than 1. For that you have to calculate the pressure. Here, let me tell you. So this is my graph. Suppose this is my graph, okay, and this is the time, this is the deflection. So what will happen if it is over consolidated? What will happen? At the initial stage, when you apply the load, there is settlement is there. But in case if it is over consolidated soil, the settlement will not take place. This curve becomes horizontal. Once it crosses the load which you applied in the past, after that settlement will start. Suppose now what is the shear strength? Because when I talk about shear, yes, it is how to be. Inside we are doing that way compression we are doing shear like this one. So this is called the shear strength. So shear strength of soil we can find the maximum resistance that the soil can offer before failure along any plane. Okay, it is called the shear strength. That plane can be circular, plane depends upon the soil. Okay. So the shear strength of the soil, there are two factors for which are responsible for the shear strength. One is the angle of internal friction, second is the motion. Why internal friction? Because the soil particles are interlocked together and there is a friction. So that's why this is the friction. Other is the motion. Because in case of the soil particles, and when we're talking about the particles which are present on the okay, there are clay particles, there are interparticle forces are there. So that's why the soil has the motion. So when you talk about the non-classic soil, they have 5. When you talk about the classic soil, they have C. But in case the soil is a combination of the all side of the particle, the soil has C and 5. So these are the failure. In case of this, you can say on column footing, this is your failure plane. It will feel like that, and shear strength will be mobilized along this plane in this direction, against the failure direction. This is your slope failure. The slope will feel like this one. The shear strength will be mobilized in that. Yeah. This is the failure of the derivative. Here you know, along with the derivative, the complete wedge is formed, and it has been taken away from the soil. So here the filling plane is straight line, planar plane. So regarding the shear strength, Coulomb has given formula. According to Coulomb, the shear strength equal to C plus sigma tan phi. What is the sigma? Sigma is the normal stress. C and phi depend upon the soil. So this is the base. This is the, you can say, first formula that was given for the shear strength. Here C and phi depend upon the dot factor like grain size and resist. And second thing is the drainage conditions, moisture content. In soil, moisture content is very important. The morning I told you when the soil is dry, it has good shear strength. The same soil, Okay, the same oil ratio, but if it's saturated, it has a different way. So shear strength will depend upon the drainage condition, water content. Later on, Karjagi corrected this formula. He told that no, shear strength equal to C dash plus sigma dash 10 phi. What is the sigma dash? Sigma minus u. Because what happened? Soil pores contains the water. So when you apply the load on the soil, what will happen? The load is taken by the water plus soil. So he said, no, we should take an amount only the water of the force that is taken by the soil particle. So he given this formula. My effective stress will be normal stress will be sigma minus u. According to that's why here give the formula and the C dash is the effective portion, phi dash is the effective angle of the friction. So later Moore Coulomb gave formula for this CSM. He has he has developed a curve between the shear strength and the normal stress. According to him, shear strength equal to C plus sigma times phi, and this is the failure angle. Where it cut the means shear strength, we are cut the C dash, and this is the phi dash. But according to the means Moore criteria, if I extend it, this is straight. This is my failure angle is straight line. But this is only applicable to the non-positive soil and sandy soil. If we talk about the positive soil, this is not correct. This actually happens in case of the positive soil. Your failure angle is not straight. So in case of the sandy soil, we can say okay, my failure angle is straight. But in case of the positive soil, so now the question: how you determine the shear strength in the laboratory? Yeah. So these are different kinds of soil. So in the laboratory, we determine the shear strength by following method: direction test, traction test, interval compression test, gain shear test. So today we are talking about this direct shear test and the traction shear. So what is the direct shear test? I think we will say everybody is. What is the direct shear test? Anybody guess? Nobody going to judge them.
direct load एक पहले डिफाइन करते हैं वो अप्लाई करते हैं उसमें कितना सेट
बेसिकली डायरेक्ट शिफ्ट टेस्ट में आप ओके कम क्लियर डायरेक्ट शिफ्ट टेस्ट में आप जो सैंपल लेते हैं यू आर डायरेक्ट शेयरिंग यू नो देयर इज शेयर बॉक्स इज देयर ऑफ द शेयर बॉक्स इज टू पार्ट्स upper shear box and direct shear box. You fill the sample and you apply the horizontal load and you apply the normal load. You determine to shear the sample how much of this is shearing. So this is simply the direct shear test. So this is your shear box. So to determine the shear strength by the direct shear test, what you do? If you take the sample either of the you can say your MDD multimeter, you pack the sample in this test and the MDD, and this shear box has the two parts. One is the upper and then there is the lower part. Okay. The normal size of the shear box is 6 cm by 6 cm. But if you have the particle more than that one, so we have the shear box of the 30 by 30 cm. More bigger, it is very difficult to conduct the test. So this is a typical picture. Okay, this is your shear box. You pack the sample in the shear box at the density. After that, you put in this water jacket and you fill it up, and you allow it to saturate. Because when you are going to test the soil, we are testing in saturated conditions. Why? Because when soil is fully saturated, in saturated condition, it is in its weakest form. So whenever we are testing the sample, For this reason, we will test it in saturated state. We allow to saturate it. So the lower box moves on the rollers, and the upper box through a yoke is attached with either a load cell or a provisional. And the lower box will have with some gear system is there that automatically that moves the lower parts. This one, yeah, this is the machine. This is a gear box. Lower box is attached with this one. When we run the machine, the lower box is moving. Now, depending upon the soil, you determine what kind of the test you want to conduct. Undrained test or the drain test. You choose the speed of the machine. If you want to conduct the undrained test, drain test means when you are testing a sample, you will not allow any water to come out from the sample. So in that case, there are the two kinds of plates are there. One are the perforated plates, other are the plain plates. For the undrained test, you are using the normal plates. But for the drain test, when the speed of the sharing the sample will be very low, okay, and you are using the perforated plates. So for a single test, you have to test at least 3 samples. In the first case, you apply the 1 kg load and they share the sample and take the damage for sharing the sample. When they can say a different time interval, you are measuring the deflection and how much the load is coming. So basically, what you are doing. So this is the picture. You can see another 1 kg normal load. With the time you are measuring the deflection and how the load is coming. After that, you plotting the curve. This is 1 kg normal load. This is 2 kg normal load. This is 3 kg. This is 4 kg. From this curve, you determine where the maximum shear stress on which sample is failing. Once you know the maximum shear stress, you plot the curve between the shear stress and the normal stress. Here, this will be the angle of friction. Okay. This is for the sandy soil. In case of the clay soil, it will cut like here, and this intercept will give the C value. It is a very quick test, and I think it is a 1 day when conducted. So, second is the unconfined compression test. This is also called an conformity and drain test, PU test. What is that? As you read it, unconsolidated. We have just listened about the consolidation. It means we are not allowing the consolidation and drained. We are not allowing the water to come out from this. So tests which are conducted in those conditions is called as unconsolidated and drain test. Okay. To conduct this test, we require you can say loading frame or the compressor machine, and we take a sample whose diameter to length ratio is 1:2. So this is the compression machine. So normally we take the sample around 38 mm dia, 50 mm dia, and the height of the sample depending upon the dia could be 76 and 100 mm. So you put the sample on the pedestal and you attach a provision, you can say dial gauge here to measure the compression of the machine, and the load is applied through this flowing ring. So with the time you run the machine, with the time you measure the deflection, the load might be coming in. After that you plot the curve. When the sample fails, that gives the maximum compression strength. So these are things. This is stress. This is my deflection. So here it is failing here, but failing here like this one. So this is that stress is called as the UCS, unconfined compression stress. Once you know the unconfined compression stress, you calculate the unconfined compression stress by this formula. Maximum load by the corrected area. What is the corrected area?
A upon 1 minus strain.
Why don't we use the diameter of the sample?
Sir, laterally. चेंज होता है सर स्ट्रेस अप्लाई करने के बाद चेंज
here you are compressing the sample. Length is decreasing, but the diameter is increasing. So at the field here, you need how much diameter has been increased. So by this formula, you can calculate it. Area 1 minus delta L by L is a straight. Okay. So that way you can calculate the exact diameter. Okay. So this is your unconfined compression strength, and the consolidated shear strength equal to, this is a formula, that is half of the compression strength. This is also quick test. Last one is the traction test. Normally we recommend for the traction test. Why? This is the best test for to determine the traction strength test. So anybody have any idea about the traction test?
soil sample to it was about
Please don't read it. Don't read it even. Okay. Anyway,
मतलब soil sample को एक प्रतिबल कोई भी इंटरनेट चूज करें तो मैक्सिमम पैरामीटर इस टेस्ट से निकाला
मतलब क्या करेंगे?
सर सी आई
वो तो आपका यूज है डायरेक्ट क्षेत्र से भी आ रहा है भाई आप यहाँ निकाल लें क्यों
इसमें सारे कंडीशन जैसे ड्रेन और ड्रेन कंसोलिडेटर और कंसोलिडेटर सारे मतलब पैरामीटर यूज करेंगे
पॉइंट इज दैट हम जब डायरेक्ट शेयर का टेस्ट कर रहे थे कैन यू मेजर द फोर्स प्रेशर हियर नो या नो ओके एंड यूसीएस में हमने क्या बोला unconsolidated drain test here we can test the sample in every condition unconsolidated drain consolidated undrained consolidated drain for all the conditions we test the sample. So that's why and the most important thing in case of the direction P होता है clear plane जहाँ हमारा top block और नीचे वाला जो हमारा box मिल रहे that is our failure plane. But in case of the direction we don't know which is the weakest plane. So here sample is varying from the weakest plane. Our failure plane is not predetermined. Second, this test provides the complete control over the drainage condition. The failure plane occur at the weakest place. And why we call it traction test? Because in this we apply the stress from all three directions, X, Y, Z. That's why we call it the traction test. This test is done with the measurement of the pore pressure. So this is the typical picture of the traction cell. So basically this is your traction cell. Here you take a sample, depending upon the diameter, that is 38 mm, 50 mm. The length of the sample is always kept at twice the diameter. Okay. You take the sample. If your it could be your can say natural disturbed sample. In case of the embankment, it could be a remolded sample and the entity. You take the sample and on the top and the bottom put two filter stones. Why we are putting the filter stone? Because we want to place the sample under drainage condition so the water can come out from the sample. If we want to saturate the sample, because in case of the clay soil, the humidity is very low. And in normal condition, it will take months to saturate. So certain times we apply some back pressure and give the water to the sample under pressure. So in that way we can saturate it. So over that we put a rubber membrane so that this sample do not come in direct contact with the water when your cell is filled with the water. And the pressure is applied by increasing the water pressure in the cells. And this is the loading yoke is here. From the top, we apply the, you can say, normal stress here. And the sample phase from the weakest end. You can see the picture. Water pressure is applied here, and the David stress is applied from the top. So sample is loaded from all three sides. So this is the how we test it. So you pack the sample here, apply the pressure. For this test, we should test three samples, three specimens we should test. You fill the specimen and you apply the cell pressure 1 kg, provide the deviator load and determine how much load it is failing. Again, take the same sample, but increase the cell pressure 2 kg. Again, test the sample. Again, you increase the loads. Because for a single specimen, I tell you, when you plot the curve, see this is again the picture of it. This is the automatic compactor. This is the traction cells. Uh, because for the one sample, you have to plot 3 more diagrams, and your failing arrow should touch all of them. Yes. At least you will rather for testing the 3 samples. So traction test is done under the 3 conditions: consolidated and drain test, consolidated and drain test, consolidated drain test. So anybody tell me what are these and where you can learn that? Simple, consolidated drain test. I tell you.
Post drain cycle.
Drain test. उसमें तो हम कर ही नहीं पाएंगे, उसका तो आपका सैंपल बनाने सैंड का सैंपल बना पाएंगे आप? सैंड का टेस्टिंग सैंपल से रूट पे how do you I told you consolidated means your C5 soil is there. You're not allowed to consolidate, you're not allowed to water to come out from the cell. So basically what is this says? In this test, no drainage is allowed after application of the confining pressure and the daily stress. Okay. So where it means the water content of the sample remains unchanged. Whatever the initial moisture content, the same water content remains throughout the test. So these are the things. So where you require this test? In case of the environment, in case of your tension damage, where you require that test? Any guess? Tell me. You have constructed your environment and you have used the you can say clay soil. Obviously, because in case of the environment, this is the water retaining structure. So you are going to use the same fossil soil, the clay soil. So clay soil has the low turbidity. Okay, it will take time to dissipate all the pressure. So in this test, what is happening? Whatever due to the load, the low pressure is developed, that is inside there. Okay? Moisture content has not been checked, more pressure has not been dissipated. Under those conditions, you are testing here. So whatever the parameter you are getting C and F here, they are used for the stability just after the further upstream and downstream flow, just after the construction. Second is the consolidated drain test. What is that? Consolidate your drain. Another thing is what simple says you are allowed to consolidate the sample and then you are not allowing the water to come out from it. So there are the 2 pressure there. I told you in the correction cell. One is you are applying the cell pressure. Other is you are applying the load to the daily stress, the normal load. Okay. So for this test, you allow the water under the cell pressure or under the confining pressure. But when you apply the normal load or daily stress, you do not allow the water to come out from the sample. So this is under the cell pressure, sample is consolidating, but after the application of the daily stress, no water is allowed to pass. Okay, this is the condition. Where you rate this condition in the field? In the field, have you seen this kind of condition? कि आपका स्ट्रक्चर जो है कंसोलिडेट हो गया है बट वाटर जो आता है हम लोग रिवर पे इरोजन बैंक्स वगैरह पे आपने काम किए have you seen what happened after the flood so फेलियर होता है Why it happens?
Before CPS.
Normally what happens when the river embankment of the full level, whatever the fish that is in contact with the water that becomes saturated. Okay? And if suddenly in case of the embankment, in case of the dam, your water level goes down. What will happen? Because your embankment is made of the clay. That is a very low pressure. Okay? So that face is saturated. So whatever the pressure that water put on your face, that has been withdrawn. Okay, so that phase is saturated, the pore pressure is there. Under those conditions, we check the stability. For that, for this test, we get those parameters, CM5. Okay.
Sir, in case of you did see this, so CM5 is different or same service?
Different. I told you everything depends on the moisture content and the water content in the sample. Soil is that material whose behavior is dependent upon the water content. Okay, because if you are not allowing the water to come out, the behavior will be different. Because here we are conducting as in plain test, the behavior will be different. Like in the morning, I told you once there is a stage when soil is in the liquid state, on the second time it is the shrinkage limit. All depends upon the moisture content. As the moisture content will flow like a liquid. Lower the moisture is dry, it has very good yield strength. You increase the moisture content, it will flow like a liquid. So everything depending upon the moisture content or the water content. So consolidated dent test, what is this test? I told you two conditions, tell you the third condition. Anyway, anybody does. Okay, let me tell you. You have completed your dam, okay? Your dam is operating, so what will happen? Every time there is some seepage there from the downstream phase, okay? Under those conditions, what is sitting from the downstream phase? To check the stability of the downstream phase, we conduct this test. Under this test, what we do? We allow the water to come out from the sample even after applying the confining pressure and after when you are applying the deviated state or the normal state. Because consolidated test, what we done? We have allowed the water to come out from the sample to the cell pressure, but when you apply the normal load, we do not allow the water to come out. But under this test, we have allowed the water to come out every condition. And the test is conducted in such a slow speed that there is no development of the pore pressure. So this gives us the effective CN5. But if we are measuring the pore pressure, we can calculate the effective pressure, effective CN5 from the second test, consolidated and then test. So this is the pictures. This is the sample weight here. Normal stress, cell pressure, deviated stress. This is the Mohor sample. Okay. Your cell pressure, your deviated stress. So that's why I'm saying for one test, you have to test three specimens. 1 kg per cell pressure, 2 kg cell pressure, 3 kg cell pressure. This is your failure number. So if you take the two, it could be that if one of the wrong, you cannot say. But in three, you can say, okay, this is test, my second test results are not okay. I have to test it again. So at least three specimens should be tested. So after saying this, anybody can tell me when the sample will fail? This is my failure. Okay? Sample will fail above this line, not this line. When the stresses are above this line, sample will never fail. Okay? So we have taken now I will take 15 rubber balls. So these are the we are talking about the normal soil. Right from the morning we are talking about the normal soil. But there are certain soils which we call as problematic soil. Why we call it problematic soils? Because these are the soils which create problems either during the construction or even after construction, post construction. So these are called as the problematic soils. Why they create the problems? Because they have some minerals, chemicals, or some formation. Due to that, they create the problems. These soils are expensive soils, dispersive soils, acidic soils, alkaline soils. So today there are the two main soils. We discuss expansive and dispersive soils. So this is the picture of the expansive soil. Black bottom soil. Okay. So these are called the expansive soils. So what is the problem with the expansive soils? सुबह के बारे में मॉर्निंग में हमने बहुत सारी बातें एक्टिविटी की बात की हमने सेंसिटिविटी की बात की what are the problems with the expensive soils? Why don't we use the expensive soil? I told in the morning we don't allow the use CS kind of soils. Why?
So much volume.
Volume. Because the only problem with the expensive soil is that with the change of the moisture content, this goes under a large volume change. Okay? When they are fully saturated, they are highly, their volume is quite large, but they don't have the shear strength. When they are dry, they shake and they develop the cracks. At that time, they have a good strength, but the cracks are there. And if it is water retaining structure, water will pass through it. So normally we don't use expensive soil. So these are some pictures, the soil failures which are made of the expensive soils. This is a picture of the stone maker. We have done this on this project because they have used the expensive soil. So they applied many solutions for the you can say stabilization slopes, but they fails. After CSMRS has given some solutions, and after that it worked well. So expensive soils, as you told you, they are also called as the black bottom soil. Why you call it black bottom soil? Because they are black in colors. And if we talk about the India, around 20% land is covered by black bottom soil. Where it is found in India? Any guess? MP good, Maharashtra good, any other states? Gujarat is also good. Gujarat, it's a part of the Rajasthan also, and it is found in the level south, Andhra. Okay. So this is a soil map. You can see it here. Gujarat, Maharashtra, MP, Karnataka is found here. So how you characterize the soils? मतलब आपके पास you have got black bottom soil. Okay. So there is one let's say identification method is the classification. Either you say this is the CS kind of soil. Okay. So that is the one thing. There is one thing. How we determine the volume change. So these are the methods which are used for to determine whether a particular grain soil is expensive soil or the normal soil. First is the free swell index, second is the swelling pressure test, third is the salinity. The morning we talked about the morning salinity. So what is the free swell index? Free swell means we are allowing the free swelling of the soil. Okay. On the basis we say this is my swelling soil or not. So what we do in that is we take some sample passing through force 25 microns and we put it into 2 glass cylinder. In one cylinder we fill the still water and in the second cylinder we fill some non-polar liquid kerosene, normally kerosene, and we shake it properly and after 20 hours we will measure the volume in both the cylinder. Depending upon that volume, we can say this is my expensive soil because when the soil will come in contact with the water, they will swell, and it is other than in the cylinder in which we put the kerosene, it will not swell. So if the difference of both of them will give whether how much swelling is present. Depending upon the swelling, we can say this is swelling soil or non-swelling soil. If our fluid index is less than 50%, low, 50 to 100, medium, 100 to 200, high, and it is critical. More than 200, very high, very severe. Okay. So basically, there in the morning, as I told you in the morning, there are three minerals are there: carbonite, light, monochrome. So this characteristic is because of the monochrome. Second is the swelling pressure test. What is the swelling pressure? Because expensive soil has the characteristics to expand when it comes in contact with the water. Okay? So if you define the swelling of the soil, what will happen? It will apply the pressure. Okay. How much the soil will apply the pressure? We determine that is called the swelling pressure. To determine the swelling pressure, we conduct the consolidation test. In the consolidation test, we allow to swell the soils. After that, we apply the loads and we bring it to its original thickness, and then we determine under which load or which stress it is coming to that present position. That is called as the swelling pressure. So depending upon the extensive swelling pressure, we can say whether it's swelling or the non-swelling. If swelling pressure is more than 2.5, medium, 2.5 to 9.8, high, more than 9.8, it is very. Third is the shrinkage limit. We have determined the shrinkage limit. Basis on that, we can say if the shrinkage limit is more than 15, then you don't have to fear about the swelling. It's a non-swelling soil. But if your shrinkage limit is less than 11, say 12, it is your expensive soil. So you have so when you are going for the, you can say, pigment, anything, you should choose a soil which has the shrinkage limit more than 12. Between 11 to 15, medium, but beyond 15, that is okay. But the shrinkage limit is less than 12, you should not allow. Second are the dispersive soil. What are the dispersive soils? Have you heard this name, dispersive?
Soil
नहीं, that is a soil structure. Flocculated structure है, आपका dispersive structure है. ये है dispersive soils. Basically, dispersive soil are your clay soils. When we talk about that, such soils they are clay soil. But what is happening there? These soils have the high content of sodium. Okay. So in normal clay soils, there is the net force among the particles is attractive force. But due to the high percentage of the sodium, here the net force among the soil particles is the repulsion. Okay. So when these soils come in contact with water, so what will happen? The soil particle will go to the water. Even the particle is not formed. It will deteriorate. So those soils are called as the dispersive soils. How you identify is by particular clay dispersive or not? Because if you construct your document with the dispersive soil, what will happen? It will come in contact with water and definitely the fighting will take place and will go. So it is mandatory to check for the soil for the dispersivity of the soils. So there are the certain tests we will conduct to identify these dispersive soils. So these are things. These are the physical things. If you go to the bore area, when you are selecting your bore area, these are the general kind of things. You see these kind of things in your field. Don't select the area because normally what is happening? Sinkhole formation. Sinkhole formation takes place in dispersive soils. Where you find the cracks there. Cracks are also available in expensive soil, but here white layer is also.
sodium.
Sodium, yeah. You can also see the slopes are also there. Deep, you can say. So these are the four methods which are used to characterize the identify the dispersive soil. First is the SES double hydrometer method. Second is current, Sherrod pinhole test, and chemical analysis of more water excess. We conduct all these tests, and based on the all four tests, we conclude whether this soil is dispersive or not. What is the double hydrometer test? In the morning, when we're talking about the grain size analysis, I told you hydrometer test. Basically, the grain size analysis. So here, what you are doing, you are doing the grain size analysis. One is dispersing agent, other is without dispersing agent, and you determine the percentage of the particles which are less than 5 micron. Because what will happen in case of the clay soil, we are using the dispersing agent to deflocate the soil, to separate the soil particles. But since it is a dispersive soil, we don't require any dispersing agent. Okay, it will automatically deflocate in the soil. So it determines the how much percentage is coming without dispersing agent, and what is the percentage of the particle with dispersing agent. The ratio of the, you can say, both give you the dispersion, percent dispersion. So depending upon the dispersion, you can say this is a dispersive or not. Dispersive is less than 30%, not dispersive. 30 to 50, that is a more than 50, dispersive. Simple grain size analysis. Current test. In this set, what we do? Take a sample and make the small balls and air dry it. After that, take some distilled water in a beaker and put that ball in the water and observe it after 5 minutes. If the soil is dispersive, what will happen? Like this one. You can see it here. The soil is there. It has not crumbled. Here it is crumbled. Okay. Thing is that, but there is no, you can say, the color of the liquid. Here too, you have to observe the color of the liquid. In case of the dispersive soil, what will happen? Whitish cloud, you will see the whitish cloud in the beaker. Depending upon the whitish cloud, sometimes what will happen, the whitish cloud is covering at the top of the specimen, and sometimes you will find the whitish cloud has covered the whole bottom of the specimen, the beaker. Depending upon that condition, you will say there are the four categories: non-dispersive, no reaction, slight reaction, moderate reaction. Depend upon that, you will say non-dispersive, moderately dispersive, highly dispersive. Pinhole test. Basically, this is the most important. Most of the time, if we your sample fails in gram test, the double hydrometer test, but if it's passing the pinhole test, it is okay. You can use that one. Because here we are creating the same condition as according to the field condition. So here what we are doing. So this is the typical picture of the pinhole test. Here, this is the glass cylinder is there. We have packed the sample here at 95% NAD. Okay, what we do? There is a cone is there, which has a diameter of 1.5 mm. On the one side, we insert the cone in the sample, and with the help of the wire that has a diameter of 1 mm, we make a hole throughout the specimen. Okay, and with both sides of the specimen, we put the steel mesh, and the gravel is packed on both the sides. Now the water is supplied through this cone at different heads, and depending upon the condition of the water, whether it's dirty water coming, whole size is decreasing, we can say the same condition that is happening in the piping in the dams. So we are creating the same condition. If the sample is passing this test, it means the soil is okay. So depending upon the, you can say, condition of the specimen, we decide whether it is dispersive or not. So these are the tables. So under the 50 millimeter head, if you find that your flow rate is more than 1.5, it means, and the water is turbid, it's coming to dispersing category 1. If it is coming clear, run for the 10 minutes, and this flow rate is coming less than around 1, then dispersing but category D2. And if it is clear, then you go for the ND4. Again, increase the water at 180 to 380, and again determine again observe the water and the flow rate. Depending upon, you can say this is MD3 category. After that, you increase the water at around 1 meter, 1.020, and check how much water is, what is the flow rate, and what is the color of the water. Depending upon the color and the flow rate, you decide this MD1 and MD3. No dispersion. So these are the 6 categories. Last one is the chemical analysis of pore water extract. Because we are talking about the sodium. Here what we are doing, we are determining the percentage of the salt or the increase in the soil by the chemical method. So here we take the pore water and we determine what is the percentage of the calcium, magnesium, sodium, and potassium. Yeah. And based upon that, we determine what is the percentage of the sodium on the basis of the total increase percentage in the water, the pore water. Depending upon the sodium percentage, if it is more than 60%, it is a dispersive soil. 40 to 60, intermediate less than 40. So now this is the conclusion. We have conducted 4 tests: pinhole test, dispersion test, curve test, chemical analysis. If your sample is coming intermediate in pinhole test, but it passing dispersion test, curve test, and chemical analysis, it was saying my sodium percentage is more than 60% for a dispersive. So what you will say? It is intermediate category because both those are non-dispersive, like this one. So this is the picture of the dispersive soils. It happens. Last but not the least, whenever you want to make any environment, whatever the soil you are taking from the bore, you should also check for the chemical analysis. Because what is happening, the soil may contain some harmful chemicals, yeah, which affect your structure. Then the foundations also, it may contain some harmful chemical like calcium carbonate, sulfates, chlorides, defense chlorides, the steel chloride, sulfate, the concrete will touch in chloride, it will attack the concrete. Later the pH value, again it will attack on the concrete. So you should also done one test. On one more area, at least one sample should be tested for the chemical. These are the scores.
Thank you, sir.
Thank you. Any questions? Any good questions? Because we have so I think there is no question. Thank you. It was a long day. Night, taking about soil structure and geosynthetics. इसमें क्या हुआ? चला स्किप कहाँ पे है? डेट कर दो
सर हम दिल्ली आए थे अटेंड करने आपके वहाँ ट्रेनिंग दिसंबर में।
हाँ
वहाँ तो कुछ समझ नहीं आया, ये अब पूरा समझ में आ रहा है।
अच्छा जब अभी आप दिसंबर में आए थे क्या?
वो 2 दिन की हाइड्रोलिक मॉडलिंग थी ना।
अच्छा
वो हाइड्रोलिक मॉडलिंग की,
न्यूमेरिकल मॉडलिंग
न्यूमेरिकल मॉडलिंग
वो एक अलग फील्ड है, ये अलग फील्ड है, ठीक है ना? वो भी होता है, वो भी होता है, कई बार
ऊपर के था
ऊपर से जा रहा है। क्या बंद करके वो लेक्चर दिखाइए मेरा, वो डिलीट स्ट्रीमिंग बंद कर दीजिएगा और स्टॉप